Anyone? So define filter. Anyone respond me?
Yes, a filter is a device which allows a particular frequency. I guess as per the requirement, like low pass filter and high pass filter or band pass. So as per the requirement, it allows a particular uh, set of band of frequency for next operation.
Oh yeah, thank you. So define active filter. Active filter means anyone. Active filter.
Active filter, those filters which have active components in the
Okay, what type components? Example?
like amplifier or something.
Yeah.
Yeah, op amp or any amplifier will be there, that active filter.
Oh yeah. Good. So define characteristics impedance. Define characteristics impedance.
So if characteristics impedance is the impedance of antenna, it is around 50 ohms, sir.
Okay. Okay, which purpose you use it? Which purpose?
Oh. It is for matching purpose, sir.
Oh yeah. Okay, next question. When we use three terminal resistor. When we use three terminal resistor. Anyone? When we use three terminal resistor.
So three
Transistor or
terminal.
register?
Ah, yeah. So please tell me, Ashish.
Yes, sir.
Tell me.
So when there is no need of for BT change, or we don't want to control with the body effect, we can use a three-terminal device, and the body is grounded always there.
Okay. Okay, Prasad, answer? Anyone?
Yeah.
Yeah, continue.
So three terminal resistors normally used for varying the resistance value for any particular application.
Okay, what particular value? Particular value. Means are greater than or less than? Anyone?
It will be using for tuning, sir, like impedance matching or for gain matching. It will be used.
Okay, actually it is used when resistor is less than one ohm. Okay.
When register is one less than 1 ohm, it is used, sir.
Yes, less than one. Yes. Okay, so next question. What are the applications of filter? What are the applications of filter? Anyone? It's a practical question. This is what are the applications of filter?
So
So
it is
filters. can be, it
Yogesh,
can be used in like it can be used in any device, like any audio devices, or in the RF applications. So
okay,
filters are used.
okay,
So for like in LNA, it is used for frequency matching. For like if we want for Bluetooth, we particularly want that 2.4 gigahertz frequency. So there can be also use a notch filter which can produce only on that frequency.
yeah,
And
yeah. It's multi-channel communication, TV broadcasting, telephony.
yes,
Yes.
communication purpose it is also used. We want particular frequency there, so we for gaining particular frequency we can use for there. So
Yeah, yeah. Okay, next question. What are the properties of RL, driving point impedance? Anyone?
please repeat the question.
Okay. What are the properties of RL, driving point impedance? RL, driving point impedance. Anyone? Sifali, Yogesh, Pressure, Ashish. So what are the properties of RL, driving point impedance?
Mm, no, sir.
Okay. So Sifali, Yogesh, Prasad, you know answer?
No, sir.
No, sir.
Okay. Actually, properties of RL driving point impedance as follows. Poles and zeros lie on the negative real axis. One point. And another point, the slope of the curve is positive at all points. Understand?
Please explain little bit more.
Okay, okay, wait. Okay, so what are the properties of RL driving impedances? So poles and zeros lie on the negative real axis. First point, and another point is the slope of the curve is positive at all points. The entity nearest to origin is a zero, and that nearest to infinite is a pole. So poles and zeros are alternate on the negative real axis. Are understand answer? Are understand guys?
Yes, sir.
Where we
Yes,
use
sir.
sir this one?
RL. So properties actually RL in circuit design.
Okay, sir. Thank you, sir.
Okay, next question. Okay, what is the difference between apparent power and reactive power? What is the difference between apparent power and reactive power? Okay, guys. So leave it. Next question. Is it possible to obtain transient free response in a RLC circuit? I can repeat. Is it possible to obtain transient free response in RLC circuit? Yes or no?
Yes, sir. Yes, sir.
How?
But it's a value of zeta should be equal to one, sir. That why. by which we can obtain its
Oh, yeah.
less than 1 or equal to 1 value of zeta,
Okay.
so we can obtain transient.
Okay. So actually answer is no. So because uh, R element, R is a dependent energy source, and L and C, so means inductor and capacitors are independent energy storage elements. So due to the in RLC circuit, it is not possible to obtain transient free response. Understand?
Okay. Yes, sir. Yes, sir.
Okay, sir. Yes,
I
understood.
can. I little confused sir. This.
Okay, question is it possible to obtain transient free response in RLC circuit? So RLC circuit, so connected in parallel or connected in series, what happens? So connected,
Yes, sir. Uh, I understood there.
okay,
Uh,
okay. So next question. Okay, next question. One micron capacitor, one 1 Henry inductor and a 10 ohms resistor are connected in parallel. The combination is driven by a unit step current. Under the steady state condition, the current source flow through which element? Are
sir, please
understood?
repeat the question.
Okay, so capacitor is 1 microfarad, one inductor, 1 Henry, and a 10 ohms resistor are connected in parallel. The combination is driven by a unit step current. Understand? Unit step
Yes, sir.
current. Under the steady state condition, the source current flow through which element?
Inductor, sir.
Inductor, sir.
Why?
Inductor.
Why?
Because in steady state, inductor act as a short circuit, capacitor act as a open circuit. So current always follow the shortest resistance path. So all current will flow through the inductor.
Oh, yeah, yeah, yeah. Good, good. So, right answer. Okay. So, next question. So what do you mean by zero phase of the signal? Anyone? Anyone answer?
Zero phase means there is no delay in propagation of signal from the source.
Okay.
Sir, please pardon the question.
Okay. So question, what do you mean by zero phase of the signal? Zero phase means,
Okay.
so magnitude
Zero.
phasor, topics actually based on circuit designer. Every circuit designer, the topics is important. Zero phase of the signal.
The zero phase means the current waveform and voltage waveform, they are in the same phase. Like there will be no delay.
Okay. Anyone? Anyone guess answer?
Pole and zero are present at origin.
Okay. Choice. Next, another.
Origin that is time tan inverse zero. So phase difference come zero.
Okay. Okay, signal is having even symmetry around zero frequency. Understand? Understand? This spectrum of a signal is having around zero frequency. So then the signal is said to have zero phase. Understand, guys?
Yes, sir.
Zero. If signal have a zero frequency, then it is zero phase signal, sir.
Ah, yeah, yeah.
That
When
mean
we are
that mean it is DC signal.
Ah, yeah.
Okay, sir.
Okay, next question. What are piecewise defined signals? What are piecewise defined signals? Anyone? Piecewise defined signals.
No idea, sir, on this.
Okay, okay. So, what is the importance of unit impulse function?
Uh, so when we use unit impulse as a input, actually when we are connect different sources at the input, in that time inductor and capacitor oppose the sudden change. But when we connect impulse as an input, inductor and capacitor accept the sudden change. Maybe this is the importance.
Okay, another one? Anyone?
Sir, it will we will check uh, the circuit failure by using the impulse function is how our circuit is behave if the a sudden change in the frequency sorry voltage or current is appear on the circuit.
Okay. Yogesh pressure, any answer?
Like, we use impulse because just to check the system response.
Okay. Okay. So capacitors are connected in parallel series. So what is the voltage at each capacitor individually? Capacitors are connected in parallel. So what is the voltage at each capacitor?
The voltage is same, sir, in parallel.
In parallel, voltage is same.
Voltage is same, current is different, but voltage is same.
In parallel or series?
In parallel, sir.
Okay. In series?
In series, current is same, sir.
Okay. Anyone? So this is correct or wrong? Okay, Ashish, actually this is wrong. So when capacitors are connected in parallel, so by using a Miller effect, Miller effect followed by Miller effect concept.
Okay, sir.
Anyone know Miller effect or don't know?
So Miller effect, I study it. It is used in for uh, analysis of frequency analysis for where the capacitor we divide the impedance into two parts of one impedance to simplify the calculation.
Okay. Try to answer what is capacitor connected in parallel, connected in series. What is the voltage at each capacitor? So what is individual capacitor? What is combined? So connected in parallel, what is the total voltage? So try to answer outside. Okay. So next question. What is the double curse effect of aliasing? What is the double curse effect of Aliasing. Anyone? What is the double curse effect of aliasing? Try to answer. Anyone? Ashish, Yogesh?
No, sir.
Okay.
No, sir.
Okay. Okay, next question. So, what is the advantages of common source? What is the advantages of common source? So,
So
common. Yeah, tell me.
it provides inverting uh, amplification and high input impedance
Okay.
and low output impedance.
Okay. So, Yogesh, this is correct or wrong?
Sir, it is correct, sir.
Okay. So, next question. What are the disadvantages of common drain? What are the disadvantages of common drain?
So in common drain, it will not provide any amplification.
Okay.
It will use for the as a buffer for the output impedance matching, sir.
Okay.
It
Impedance
will
matching
act as a
for
source
purpose of
follower.
impedance representation.
Okay.
Sir, in common drain, voltage will reduce by the 1 upon GMRS, I think.
Okay. So, what is input? What is output in common drain?
Sir,
Gate is the input, source is the output.
Oh, okay. Okay. Value. What is value?
so high input impedance is infinity and output impedance is 1 upon GM for common drain, sir.
Okay. GM.
Yes, sir. Transconductance.
The direction negative or positive?
Positive.
Oh, yeah.
If
Okay. Next question.